All right, so I want to take a look at this. This is from chapter 5, and this is about continuous distributions. And this is kind of a standard problem that we have with these particular kinds of questions. And so what we're going to do is we're going to play off the idea. So what it says is the probability density of a random variable x is given in the figure below. From this density, the probability that x is greater than 1.76 or x is less than 0.26 is, okay? And so what we want to do here is we need to figure out this probability. Well, the thing is that we're not given any, values. We're not told anything about a sample. We're not told anything about the distribution, right? So how do we go about doing this? And what we're going to do is we're going to utilize two facts, okay? One, the first fact that we're going to utilize here is the area underneath the curve for a particular interval is the probability of getting that interval, okay? And I'll explain what that means in just a minute. And the second part that we're going to use here is the total probability for any probability distribution is equal to 1. Okay? So those two facts alone are actually going to allow us to answer this entire question. So let me open this up a little bit. Okay? So I look at this question. I've got the probability density, and I'm looking at this picture right here. Okay? In fact, I need to get my pencil. Okay. Now what I want to do, what I'm looking for here is I've got, actually bigger, a little bit bigger. I want to know if x is greater than 1.76. So I'm just going to kind of estimate. I'm going to make it right about there. Okay, that's about 1.76. Okay. 1.76. All right. And 0.26 is over here. Okay. Working with the computer right now, so hence my lines aren't what I would normally want them to be. But here's 0.26 right here. Okay, there's 0.26. All right, that looks about right. And so what I'm looking for to find this probability is I'm going to look for the area here that either is in this area right here, because that's the greater than 1.76, right? That's this part. That area in there. Or I'm looking over here because this is the less than 0.26. Okay? All right. So the question is like, how do you go about finding what that area is? Well, it's basically, more than basically, it is, in fact, this is a box. These are two rectangles. And to find two rectangles, okay, this is how we solve that problem. We want to find the area, and we want to find the area. So we need to use length times width. Times width equals our area. Okay. Okay. Now, the length itself is not so hard. Okay. This length right here, from 0 to 0.26, that's 0.26 because it's 0.26 minus 0. Okay. So that's that length. So we'll call that length 1. So length 1 is 0.26 minus 0. Okay. That's basically just this side minus that side. Okay, which equals 0.26. And our length 2 is 2 minus 1.76. Okay, because it's this length right here. Okay, actually, because it is this length right here. So it's going to be 2 minus 1.76. Which equals 0.24. Okay, so now we've got the lengths that we're going to need. Okay, now what we need is we actually need to figure out what this one is. How big is this? All right, and that's actually not all that bad either. We're going to take this second fact, the fact that the total probability for any probability distribution is equal to 1. We're going to use that second fact, okay? And so what that means is, excuse me, this height, so the whole length for the entire box is 2, okay, because it goes from 2 to 0. And so the height, okay, is going to be 2 times what will give me 1, right? That's the idea, because length times width will equal the area. The area is 1, okay? So because the area is 1, length times width will equal 1. We know the length is 2, so 2x equals 1, right? And x is what we're looking for in order to give us the area for the other two boxes. So x just equals 1.5. You used a little bit of algebra there, you know, basically all the algebra that you're going to need for statistics. So x is 0.5. Now, for these two boxes, we now know, okay, 0.5. We now know that area. So what that's going to give me then is the box 1 will equal 0.26 times 0.5, and which equals 0.13. And box 2 will equal, its area will equal 0.24 times 0.5, which will equal 0.12. Okay, so their areas for each box, this first box right here has an area of 0.13. This second box has an area of 0.12. That is their area. That is their probability. Okay, area under the curve, right, for a particular interval is the probability of getting that interval. So this one has the area of 0.13. This has an area of 0.12. Well, what that means is, so because area is probability in a PDF, a probability distribution, this means that our probability is 0.13 plus 0.12, which equals 0.25. There it is. And that actually is the entirety of our problem. Okay, so really simply put, what we want to do here is we're going to figure out the lengths of the intervals, right, that we are looking for in terms of their probability. All right, and that's just a matter of figuring out these from what they've given us. X is greater than 0.176, that's the one. X is less than 0.26, that's that one. Okay, then what we need to do is we need to use this fact that the probability for any, the total probability for a probability distribution is equal to 1, and that means that if we take this length, right, okay, times some, whatever the unknown is for the height or the width, then that's going to give us 1, right, which is what we did. We found it to be 0.5. Then we just find the areas for the two boxes, because area is probability. Okay, area is probability. That's going to apply when we talk about normal distributions. It's going to apply for everything. Okay, so we went in, we found out the areas for the two boxes, added them together, and that gave us our answer. So that concludes finding the area for uniform distributions.